Hello, and welcome to part 2 of this presentation on audio loudness measurement and monitoring. My name is Mike Wadeson, and I'm an application engineer here at Tektronix. In the first part of this presentation, we discussed the ITU-1770 standard and how it had been adopted by ATSC in RP-A85 and by the EBU in R128 standards. In this second installment, we're going to discuss the way in which audio loudness measurements can be made on Tektronix Waveform Monitors and Rasterizers. There are a wide variety of audio programs, from music to sports, to talk shows, dramas, comedies, movies and commercials. Each of these audio programs have different dynamic ranges and different audio levels dependent on the content of the program. We can represent these various audio programs by different tools that represent their different audio levels. The audio engineer has a variety of tools at his disposal to produce these programs and monitor the audio levels using level meters or a Lysergic display and surround sound displays that aid in maintaining levels of audio programs. Now there is another tool that can be used, the audio loudness meter, and in this presentation we're going to discuss how to measure audio loudness using the WFM 8300 series waveform monitor. But the same techniques can be used on the Tektronix 7000 and 5200 series waveform monitors or rasterizers. The purpose of loudness measurements is to find the center of gravity of the audio program, the average level of the audio, and establish an overall loudness level for each program that will be the same across the variety of program materials. Therefore, if the average level of loudness is measured for each program and adjusted as necessary to meet the overall loudness level, then there will be consistency between programs or commercials. The dynamic range of each audio program will be different, but the overall average audio loudness level will be the same between each program and commercial. For short-form content such as commercials or promos, the complete program must be measured. For long-form content, an anchor element can be determined, which is normal dialogue, not shouting or whispering, and the loudness value for this segment can be measured. Alternatively, the user can measure the total program. In this next section, we'll discuss the measurements and how to configure them on a Tektronix waveform monitor. The loudness measurement is based on the ITU-1770 standard, using the loudness measurement equations that produce an LKFS loudness K-weighted full-scale value. This measurement is based on the number of audio channels that are included in the summation, denoted by n within the equation. The measurement can be made over an average duration. This duration can be a short period, typically 10 seconds. Within the waveform monitor, this period can range from 1 to 60 seconds and is configured by the user. The infinite duration measurement is based on the duration of the audio session over which the measurement has been monitored. There are a variety of settings within the loudness configuration of the loudness meter. For the ATSC standard, the target loudness is set to -24 LKFS, with a deviation of plus or minus 2 LKFS. And the user or program provider can define upper and lower thresholds for what they define as too loud or too quiet. There are a variety of Tektronix waveform monitors or rasterizers that provide capabilities for loudness measurement. In the 8000 series or 7200, an audio option is required in order to monitor loudness within the instrument. For the 7120, 7020, or 6000 series, an audio option is also required for loudness monitoring. If the user wishes to log the audio loudness measurements, then the A-log option is also required. For the 5200 series, the audio option AUD and loudness option Loud are required. In the next few slides, we'll provide details on how to make loudness measurements on the WFM 8300. However, the configurations and settings are very similar between the various products. To configure the WFM 8300 for loudness measurements, press the Configure button to enter the configuration menu and navigate to the loudness settings submenu. Within this submenu, there are a variety of settings that can be configured by the user. To simplify operation, there are several loudness presets with pre-configured settings. Select the ATSC 85 settings to load the configurations that are in compliance with this recommended practice. When the preset is loaded, the values that are changed by the preset are shown in yellow. You may also wish to configure the audio input-output menu for your specific audio configuration. The audio program configuration determines which channels are summed together in the program loudness. So, for instance, if you have a stereo audio program, then the 4x2 audio configuration would be preferred. If you are listening to a surround sound mix, then one of the multi-channel audio configurations, such as 5.1+2, may be used. The ATSC 85 preset configures the following settings. The loudness filter is selected to use the LKFS 1770 pre-filter and RLB filter for the measurement. The short duration period is set to 10 seconds for the short duration average. The infinite duration average is based on the period of the audio session, which can be manually started and stopped or reset by the user. The channel weighting for the summation of channels is set to the ITU-1770 standard that provides weighting of the surround channels by plus 1.5 dB. The target loudness is set to minus 24 LKFS with a high and low setting of 2 loudness units. By using these simply pre-configured presets, the user can quickly set up the instrument for loudness measurements. Within the loudness settings menu of the WFM 8300, the user can select the EBU-R 128 preset that configures the instrument to use the following settings. The loudness filter is selected to use the LKFS ITU-R BS.1770 filter for the measurement. A momentary integration time of 400 milliseconds is used, and the average short period duration is set to 3 seconds for the short duration average. The infinite duration average is based on the period of the audio session, which can be manually started and stopped or reset by the user. The channel weighting for the summation of channels is set to the ITU BS.1770 standard that provides weighting of the surround channels by plus 1.5 dB. The target loudness is set to minus 23 LUFS and a high-low setting of 1 loudness unit. Note that the loudness unit is a relative scale, and the loudness meter can be set up to use an LU scale where the target loudness is defined as 0 LU value. This can be configured within the configuration menu of the loudness settings. The gating function is set to relative measurement with a relative gating level of 10 loudness units. Gating is where the audio loudness level falls below a threshold and no measurement of loudness are included in the infinite measurement. An in-bar message will be shown in loudness meter when gating is being applied. Additionally, a safety gate is also applied when the level drops below minus 70 LUFS. By using these simple pre-configured presets, the user can quickly set up the instrument for loudness measurements, or can use an instrument preset to load a user configuration. Within the audio tile, the loudness meter can be enabled within the audio tile menu, accessed by pushing and holding the audio tile button. The audio display shows the meter enabled and the PL beneath the bar indicates that the meter is currently configured to show the program loudness. The loudness measurement in this case is based on the summation of certain audio channels. The green label used for the audio bar indication shows that this channel is included within the measurement. An audio label shown in white indicates that this channel is not included in the measurement. A variety of user-defined limits can be set up for the loudness meter, and we will discuss these in detail in the next slide. At the top right of the display are a variety of measurements and loudness information that provide loudness measurement values for the short and infinite duration, along with the maximum true peak and dial norm values. The runtime of the audio session is also included within the audio tile. When the loudness meter is enabled within the audio tile, it provides a variety of information. The white diamond on the right-hand side of the meter indicates the user-defined target loudness, which is -24 LKFS for the ATSC standard. A user-defined upper and lower range of allowed loudness is shown by the yellow and blue diamonds. For the ATSC standard, plus or minus 2 loudness units are allowed. The user can also define their own thresholds for classifications of what they consider too loud, shown by the red diamond, and what is considered too quiet, shown by the grey diamond. In-bar messages will also be displayed if gating is being performed by the loudness measurement, or if the signal is too loud or too quiet. The audio session display is where the user can find a summary of the audio measurements performed by the instrument. Summaries of clips, overs, mute, and silence conditions present during the session are shown for each channel, along with the peak and high audio levels that have occurred during the session. The loudness measurements are shown per channel and for the pairs of channels, along with the overall and short loudness measurements. For informational purposes, the duration of the short period and the number of channels used within the summation of the measurement are also provided. The runtime value shows how long the session has been running, and the session can be manually started, stopped, or reset by the user. The trend chart shows the loudness value every second for a duration window of 90 seconds or 180 seconds. For longer durations, a bar chart is used to show the minimum and maximum loudness values during each bar. The loudness chart supports from 7.5 minutes to 30 hours duration. In earlier versions of firmware on the 7120, 7020, and 6000 series, the duration was 9 minutes to 6 hours. Please make sure to load the latest version of firmware available from the Tektronix website that now supports up to 30 hours on the 7000 series. Note that the A-log option is required to view the loudness session and save the loudness values to a USB device or via the network for the 7120, 7020, and 6000 series. Here we can see the loudness bar chart, showing the maximum and minimum loudness values for each bar period. Below the chart is a variety of information. The current loudness measurement for both short and infinite values are shown, along with the dial norm and true peak values. The maximum and minimum loudness values are reported for the session, along with summary information for the channel summation, short period duration, and target loudness. The user can save the loudness data to a USB device or via network connection from the instrument. This allows the user to save the loudness data for further analysis. The data can be easily imported into a spreadsheet application, and a variety of charts and reports can be created. Here you can see the exported data within a spreadsheet application that has been obtained from the instrument. By using the data of the spreadsheet application, a graph can be drawn of the data values obtained from the instrument. This data can then be manipulated in a variety of ways to suit the customer's requirements. In this next section, we'll discuss Dolby Metadata, and how this data can be added within a facility to support multi-channel audio, and how the signals are distributed throughout the system. Dolby metadata is carried within the digital data stream and includes 28 different parameters. Some of these parameters are informative and have no effect on audio decoding. There are 19 basic parameters that are provided to optimize the listening experience, such as dynamic range and downmix. There are 2 parameters that are critical and required for proper encoding and decoding of the data stream. Channel mode describes the channel format, and dialogue level, also referred to as dial norm, describes the average dialogue level. Within the Tektronix instruments, the Dolby status menu provides information on the Dolby metadata and can be extracted from the audio data stream or via metadata in the vertical ancillary data space that conforms to SMPTE 2020. Section 7 of the ATSC standard describes 3 methods of using audio metadata: fixed, preset, or agile. The fixed method sets the dialogue level to a single fixed value. The second preset method allows the encoder to be programmed with different dial norm values based on presets loaded to the equipment. The agile method allows the encoder to be configured by receiving external metadata that programs the equipment. Any one of these approaches will deliver consistent loudness to the listener. The broadcaster is free to use one of these methods that best suits their operational practices. Whichever approach is selected, the system depends on transmitting a value of dial norm that correctly represents the dialogue level of the content, which depends in turn on accurate loudness measurements. Using a fixed dial norm setting means the long-term loudness of the audio program output should be measured and the dial norm will be set to this value. The content delivery specification should set the target loudness of the ingest of the material, and any non-conforming audio needs to be measured and an appropriate offset applied in order to conform to the transmission requirements. This approach poses minimal risk to content and simplifies system requirements. Another approach is to change between the various presets that are loaded within the AC3 encoder, and use an external device to trigger these changes. Various presets are loaded within the AC3 encoder based on known differences in content loudness. An automation system is then used to recall these presets based on content and channel modes. Care has to be taken in ensuring correct frame sync, as some encoders can disrupt the audio stream when a preset change is made. This will result in an audible glitch to the transmission output. This mode is often used when changes have to be made between stereo and multi-channel audio programs. An agile metadata system involves setting a different dial norm value for each piece of content. The metadata is extracted at the input of the system and placed within the SDI and status space in conformance with SMPTE 2020. This metadata is then carried with the material throughout the broadcast chain. Just prior to the AC3 encoder, the metadata is de-embedded from the SDI signal and applied to the encoder, allowing dial norm settings to be changed appropriately on boundaries of content. This approach requires that the system be employed throughout the facility. An agile system is the most complex and requires full loudness measurements of each piece of content. An agile infrastructure is required throughout the broadcast plant, and equipment must be deployed at all input and output monitoring locations. There is the potential for the loss of the metadata that could result in audio discrepancies. If the metadata is removed from the signal, or additional SMPTE 2020 packets are added to the SDI signal. An agile system provides the most flexibility for the content provider, as it does not impose creative limits on the program material. An agile system is extremely flexible, but can be challenging to implement effectively within a broadcast system. An alternative is to use a hybrid approach that combines the simplicity of the fixed system with the flexibility of the agile system and creating a fixed agile hybrid. In this case, the incoming signals are delivered in Dolby E and the metadata is extracted from the Dolby data stream and encoded within the SMPTE 2020 standard as vertical ancillary data. This is typically inserted into line 9 of an HD SDI signal and routed throughout the plant till finally the signal is distributed. At the Network Distribution Center, multiple sources are routed and transmitted, and during this process the Dolby vertical ancillary data is extracted from the SDI signal and applied to the Dolby E encoder. A stereo downmix of multi-channel audio is also provided, so that the MPEG encoder provides a video stream and various audio data streams for transmission to affiliates. Typically, only a limited set of metadata modes are allowed to simplify system implementation. The idea within these systems is to effectively control the loudness between programs and commercial material. Using the fixed dial norm method, operators need to ensure all content meets the target loudness and that their long-term loudness measurements match the dial norm value. In the case of file-based material, a scaling device can be used to match long-term loudness automatically, while in real time a loudness processing device can be used to match loudness. For an Agile system, all program content needs to have loudness measurements made, and the dial norm value should match the actual calculated loudness measurement. For file-based content, the dial norm should be set based on specific loudness of the content. In the case of news or live events, real-time monitoring should be done to match content-specific loudness, and set dial norm based on this loudness measurement. The dynamic range control parameters are calculated based on the indicated loudness. Therefore, the dial norm value needs to accurately reflect the loudness of the audio data. For Dolby E professional encoding, there are a range of profiles that can be contained within the metadata. These profiles are compatible with Dolby Digital dynamic range parameters for line and RF modes. A dynamic range control of none could be set, but this is not recommended, as this inhibits the generation of dynamic range control profiles and prevents the viewer from selecting these modes at home. Additionally, there will be no limit protection available when there is no dynamic range control selected. Dynamic range can be used to limit the overall dynamic range of the audio program by boosting the low audio levels and cutting the upper audio levels so that viewers can listen at a comfortable level. The Dolby data stream is capable of delivering the full wide dynamic range of the program. However, the viewer at home may wish to limit the extreme variations in audio levels. Maybe they have a baby that's just gone to sleep, or they don't want to disturb the neighbors with loud audio levels. In these types of cases, the receiver may be able to limit this wide dynamic range by the use of Dolby metadata contained within the signal. Although there is no formal naming convention for the operation mode within the receiver, it may be termed the midnight mode or similar selection. This mode uses the line mode metadata values to limit the dynamic range. This provides boost to the low-level signals so that quiet sections of the audio can be heard at a comfortable listening level. For loud sounds, cut is provided to limit the higher audio levels of these signals and reduce gain to produce again an audio signal at a comfortable listening level, allowing this wide dynamic range of content to be limited by these dynamic range control parameters. Using this method of dynamic range control, it's important that the dialogue level is set appropriately, otherwise the signals could be misadjusted by the receiver. The Dolby AC3 system provides these dynamic range parameters that are part of the audio encoding process. This allows the program producer to deliver a wide dynamic range for the audio within the content. The viewer at home can choose the mode depending on the type of equipment they're using. The overall goal of this type of dynamic range management is to preserve the original dynamic range of the content and provide the viewer with the choice. Traditionally, in audio system compression and limiting, gain control was applied prior to distributing the audio, and once the process had been applied, the audio signal cannot be restored to the original content. In the case of Dolby AC3 encoding system, the gain control words are generated as part of the encoding process. These dynamic range parameters are carried within the metadata. The gain control is not applied during the encoding process, but can be applied by the user during the decoding process, allowing the user to control how much dynamic range is desired within the listening environment. Therefore, AC3 is a reversible process, whereas the traditional method is not. Within the waveform monitor, the dynamic range parameters can be displayed within the Dolby status display that decodes the metadata. Additionally, for monitoring of the audio, these dynamic range parameters can be applied for the line and RF modes to the audio outputs. This configuration is selectable within the Dolby D setup parameters within the configuration menu. As I mentioned earlier, it is believed that louder is better, and this will grab the attention of the viewer. Sometimes, though, these extreme variations in audio level go outside the comfort zone for the listening environment and cause the viewer to reach for the remote control in order to adjust the volume level. This can sometimes lead the viewer to have to adjust the volume between commercial breaks and the regular programs, and that can become very annoying for the customer who continually has to reach for the remote control. In the United States, this has led to the CARM bill. You can find out more about this bill, H.R. 6209, the Commercial Advertisement Loudness Mitigation Act, on various websites. Some other countries around the world already have legal requirements for broadcasters regarding loudness of program material, and others are considering regulation. To summarize these recommendations, the purpose of the ATSC Recommended Practice A85 is to lessen the negative impact loudness variations can have in the listening environment. In order to achieve this, it's important to ensure that the target average loudness is maintained when a fixed metadata system is used, and suitable measurement equipment should be used to monitor the loudness of the audio program. In the case of an Agile system, the dial norm should match the measured loudness content. It's important for broadcasters to create awareness with content suppliers concerning the overuse of dynamic range and the possibility of listener complaints when large loudness variations occur between programs. Additionally, the AC3 dynamic range control should not be relied on to control program loudness, and it's important that dial norm is correctly maintained within the system for consistent dynamic range control in the home. In the broadcast chain, it's important for operators to ensure dial norm matches the content loudness when using an Agile metadata system. When a network feed is decoded to baseband, the loudness of the decoded audio should be measured, and the loudness measurement should match that of the dial norm value when the signal is encoded again. If the TV station uses a different dial norm value than the network program loudness, then the operator will need to adjust the loudness so that they match. Additionally, it's important to ensure at the re-encoding stage that other metadata parameters are set appropriately so that consistency is maintained throughout the system. Audio loudness is a critical measurement to make within the broadcast chain to ensure consistent audio levels between programs. The ITU-1770, 1771, ATSC A85, and EBU-R 128 recommended practices have been adopted by broadcasters in order to standardize the measurements of audio loudness. New audio measurement techniques are required to measure the loudness of the audio signal in accordance with these standards, and new working practices are required in order that program producers and broadcasters can adhere to these practices and produce an overall consistent loudness level between programs and commercials. There is additional information on the Tektronix website, such as the how-to guide on loudness monitoring and measurement, which walks you through the steps of configuring the various waveform monitors or rasterizers to make audio loudness measurements. Thank you for watching and listening to this audio loudness monitoring and measurement seminar part 2. If you missed part 1, that's also available on the website here at Tektronix.